So now we're going to discuss measures of central tendency. And measures of central tendency are measures that actually will approximate the center of a data distribution or a set of data. So we're going to talk about the mean, the median, and the mode. The mean is the most common measure of central tendency. To calculate the mean, you simply sum all of the values and divide by the number of data values that you have, and we call that n. Now, some texts will use the sigma notation without an explanation to divide the formula for mean. I'll give a brief explanation of this concept. Suppose I have the following data: 18, 14, 17, 21, and 15. Then we could say that x1 is 18, x2 is 14, x3 is 17, x4 is 21, x5 is 15. So when you see this notation here that says we're going to sum x sub I from 1 to 5, that just means we're going to add x1 to x2 to x3 to x4 to x5 because we're adding the x's from x1 to x5. So in our example, when we sum x1 to x5, we would simply just be adding up those 5 values, and we would get 85. So the formula for the sample mean, and actually it's the same formula you would use for the population mean, would be that x bar is equal to the sum of all of your data values divided by n, where n is the total number of data values you're given. And like I said, this is also the same formula for the population mean. So if I wanted to find the mean of these 5 numbers, I would simply add the 5 numbers up and then divide by 5, and I would get a mean of 17. In the second example, I've got a set of 10 test scores, so if I wanted to find the mean of that sample, I would simply add up the 10 test scores and then divide by 10, and I get 782 divided by 10, which is 78.2. Now, the median is used when generally used when you have very large values or very small values at the end of your set of data, and you don't want those values to strongly influence the middle score. So if we don't want those extreme values to influence the middle score, we might use the median. And the median, the middle data value, or the average of the 2 middle values, is the median. Now, one thing that's important when you're calculating the median, you must put the values in ascending order first. That's the smallest to the largest. So otherwise it's a huge mistake if you don't. There's not a traditional median abbreviation, that should say median. There's not a traditional median or mode abbreviation, but some texts might use ME for median. Now, if there is an odd number of data values, the median is simply the value in the middle. If there's an even number of data values, the median is the average of the 2 middle scores. So in my set of 5 scores here, I have an odd number of data values, 5 data scores here. And notice that if you don't put them in the right order, you wouldn't get the median correct. Notice if I just looked at this and tried to get the median, I might claim that the median is 18, but that's incorrect, because first I have to put the median in. I have to put the data scores in ascending value. So I'd actually put 14 first, then 15, then 17, then 18, then 21. And now I can easily see that the median value is 17. Let's go back to my 10 test scores. Now again, you want to take these 10 test scores and put them in order. And you can see I've put them in order from the smallest to the largest value. And notice that I actually have 2 middle scores here, 77 and 81. So in this case, the median would be the average of those 2 middle scores. So just add 77 to 81 divided by 2, and you get that the median is 79. And so, and again, the reason we use the median is because the mean is not always the best measure of centrality for our purposes. For instance, consider this set of salaries from a pool of administrative assistants. Let's say the salaries are $39,000, $39,000, $40,000, $43,000, $45,000, and $79,000. Now I went ahead and wrote these in ascending order here just to simplify things. But if you were to find the mean of these 6 scores, the mean would actually be 48,500. So if you were trying to imply that the salaries were low, then this probably wouldn't be your best choice, because whoever's making this $79,000 here is really skewing the mean upwards to a value of 48,500. And maybe that's the boss's son that's getting that salary. So another way to calculate the middle score that might be more in line with what you might want to do is maybe you look at just the middle of the data. So in this case, I would have to find the average of these 2 middle scores, 40,000 and 43,000, which would be 41,500. And this would make a better case for giving everyone a raise than to show that the average score is 48,500. So the mean would give you a better case to make the argument to your boss that the salaries need to be increased. Now, if you want to find the mean with a large amount of values, or I'm sorry, the median, if you want to find the median with a large amount of values, then there is a formula that you can use. First, make sure the values are in ascending order, then calculate this number, n plus 1 divided by 2. If it's a whole number, then the median is in that position. If it's a fraction, then the median is the average of the 2 numbers before and after the number. So let me just show you here with a simple example. Here I have 1, 2, 3, 4, 5, 6, 7. So if I do n plus 1, 7 plus 1 divided by 2, I'll get 4. So that tells me the median is in the 4th position, which is 10. Now these are written in ascending order for simplification here, but remember, if they're not in ascending order, make sure you write them in ascending order first. The next example, I actually have 8 values, so I would add 1 to 8 and then divide by 2, and I would get 4.5. So that would tell me that the median is the average of the 4th and 5th position, and the 4th and 5th position are the 10 and the 12, and if I average those, I get a median of 11. Now, the last measure of central tendency that I'm going to discuss is the mode. The mode is the data that occurs most frequently. So, for example, if you look at these values here, you might want to put those in ascending order as well, because it'll allow you to see easily see the mode. So I'm going to go ahead and put them in ascending order. So I'll write the 3 2s, and then I have 4 3s, and then 3 4s, and I have 2 5s. Now I can see here that the 3s there, the 3s occur more than any other of the values, so the 3 would be the mode. So here the mode is 3. Now, what if I had the ratings of 10 judges for an event here, and let's say that I got a 6, a 7, a 7, a 8, a 8, a 8, a 9, a 9, a 9, and a 10. Well, notice this time I have 3 8s and 3 9s. So in this case, we would say this is a bimodal example because we have 2 modes. One mode is 8 and one mode is 9. Now, if all the scores occur only once, then there would be no mode. And so then this last example, this was the test scores that we used earlier. Notice in this set of test scores the 82 occurs 3 times. So on this one the mode is 82. In the next video we'll talk about measures of dispersion.